Hey, welcome back to another junior measurement video. In this video, we're going to do our second video on the volume of a prism, and we're going to introduce circular prisms or cylinders. So far we know that the volume is the amount of space inside a 3D object. For those of you who've done any work on the Colosseum, the Roman Colosseum, you probably are aware that it is not a perfect circle. It's kind of like a squash circle, and we call that an ellipse. So the Roman Colosseum was one of the first elliptical buildings ever built. All right, a prism is a mathematical shape that has a cross-section that extends along a depth. So here are the types of prisms we've spoken about: circular prisms, trapezium prisms, hexagonal prisms, triangular prisms. There's many more out there. In this video, we're going to turn our attention to a circular prism, and most people like to call it a cylinder. So a cylinder is a prism that has a circle cross-section that extends along a height. So I'll just draw some hidden lines in there. There is the cross-section. It is a circle, although it doesn't look like a circle the way we've drawn it here. If you were to look straight down on top of the prism, you would know that it's a perfect circle. Right, so this is the cross sections that's extending along the height. It just stays the same all the way down through the height. We have a radius, which is the distance from the center to the outside of the circle. If you are working on a problem that they gave you the full diameter right across, you'd have to divide that by 2 to get the radius. There's the height of the cylinder, the depth, but we prefer to call it height when we deal with cylinders. Right, so let's go back to the rule for volume of a prism. The volume of a prism is equal to the area of the cross-section times the depth. So if you look at this example here, we've got a triangle as the cross-section. If we work out the area of the triangle, then we just multiply it by the depth, right? Some people prefer area of cross-section times height, and that's what we're going to use in the cylinder because we're just going to assume the cylinder is standing up tall. Now we know the area of a cross-section is a circle, so we know the area of a circle is pi times radius squared. That's the cross-section of a cylinder, the area of a circle. So we've just got pi times radius squared times height, and we could abbreviate it in algebra to pi r squared h, because we don't do the times in algebra. So let's get into using this formula and showing you how it works. Example 1, calculate the volume of the following cylinder. So we have a height of 15 and a radius of 8 centimeters. So the volume is equal to the area of the cross-section times the height. So that's pi times radius squared times h. The cross-section, remember, is pi times radius squared. That's the area of a circle. So let's substitute r in for 8 because that's the radius of the circle, and h we're going to substitute in for 15 because that's the height. So now we've got to work out pi times 8 squared times 15. I need my calculator to help me out here. Pi times 8 squared times 15. Please make sure you remember how to get pi on your calculator. Gives me this number here. I'm going to round it to 3015.9 centimeters cubed. I've rounded it to 1 decimal place. Now remember, 1 centimeter cubed is just a small cube that's 1 centimeter by 1 centimeter by 1 centimeter, and I would need 3015.9 of these little cubes to fill up the same space as that cylinder. Okay, let's do a second example, exactly the same as the first, although the measurements are in meters, just to reinforce what's going on. So the volume is area of a cross-section times height. The cross-section is a circle, so it's pi times radius squared. We are going to substitute in the radius of 1.4, and we're going to substitute the height of 3.26. We grab our calculator and type in pi times 1.4 squared times 3.26, and we round our answer sensibly. I'm going to round it to 2 decimal places and get 20.07 meters cubed. Now remember, think about a cube that's 1 meter by 1 meter by 1 meter. I would need just over 20 of those cubes to fill up the space of the cylinder. All right, well, there's our second video on prisms. Thanks for watching.